the quantum loophole that makes time travel real. Let's be honest, we've all been told that time travel to the past is a complete non-starter. Why? In a word, paradoxes. If you pop back in time and accidentally prevent your parents from ever meeting, you'd just vanish. It's a contradiction that should logically break the entire universe. But what if that fundamental assumption is wrong? What if the universe has a built-in safety net, a quantum rule that makes paradoxes impossible and actually opens a door to the past? Einstein's theory of general relativity gives us the weird and wonderful blueprints for that door. But it's the even weirder rules of quantum mechanics that might just give us the key. Section 1. The Dream and the Wall. The dream of visiting the past is one of humanity's oldest what-ifs. Imagine it, walking with dinosaurs, witnessing the pyramids being built, seeing history with your own eyes. It's the ultimate field trip. But there's always been a massive wall standing in the way, the wall of logic. This wall is built brick by brick from paradoxes, with the most famous being the grandfather paradox. You've heard the story. A time traveler zips to the past and gets rid of their own grandfather before he can start a family. No grandpa, no parent. No parent, no time traveler. But if the time traveler was never born, who went back in time to cause all the trouble? It's a perfect self-destructing loop that seems to slam the door on any trip to yesterday. For decades, that was the end of the conversation. Time was a one-way street because allowing a U-turn would invite total chaos. But physics, especially on the cutting edge, has a funny habit of turning impossible into, well, it's complicated. What if we've been looking at this all wrong? What if the universe doesn't forbid the journey, but instead, it forbids the paradox? Section 2. Einstein's Doorway. To even entertain this cosmic plot twist, we have to start with Albert Einstein. His theory of general relativity totally rewrote our understanding of time. It's not some universal, constant clock. It's a physical dimension, woven together with space into a four-dimensional fabric called space-time. You've probably heard the analogy, a bowling ball on a trampoline. A massive object, like a star, warps the fabric of space-time, and that curvature is what we feel as gravity. But Einstein's equations allow for some truly wild possibilities. Under extreme conditions, like the mind-boggling gravity near a spinning black hole or a hypothetical, infinitely long, spinning cylinder, space-time could be twisted so intensely that it actually loops back on itself. These theoretical pathways are called closed time-like curves, or CTCs. A CTC is exactly what it sounds like, a loop in time that could allow an object to travel forward and end up at a point in its own past. So, Einstein's theory provides a mathematical blueprint for a doorway to yesterday. The problem was, for years, no one knew how to use it. A doorway is pretty useless if walking through it makes reality implode. General relativity opened the door, but the grandfather paradox was the guard standing in front, refusing to let anyone pass. That is, until the quantum world showed up with a new idea. Section 3. The Quantum Key. And this is where things get wonderfully strange. Quantum mechanics, the science of the super small, plays by rules that make no sense in our everyday lives. It's a world of probabilities, where particles can be in many places at once. And it turns out, these bizarre rules might hold the key to solving time travel paradoxes. Back in the 1980s, Russian physicist Igor Novikov proposed what he calls the principle of self-consistency. The idea is brilliantly simple. Any event that happens in the past must be self-consistent. In other words, whatever happened, happened, and your trip to the past can't change it. Novikov argued that the laws of physics would conspire to stop a paradox before it starts. If an event could create a paradox, its probability of happening is zero. So, if you go back in time to stop your grandfather from meeting your grandmother, something will stop you. You might slip on a banana peel. Your time machine might break down. Or, in a twist of irony, the distraction you cause might be the very reason they meet in the first place. The universe, according to this principle, enforces its own story. You can't change the past because your actions were always a part of it. For a while, this was just a compelling thought experiment. But some theoretical research in quantum mechanics is now hinting at how the universe might pull this off. Theoretical models and simulations suggest that events inside a closed time-like curve could naturally adjust themselves to stay logically consistent. The universe doesn't need a magical banana peel. The fundamental laws of quantum physics could make it impossible for you to succeed. If your brain is starting to bend in the best way possible, and you love exploring the biggest questions in the universe, think about subscribing. We dive into cosmic riddles like this every week, and you'll be helping us explore the frontiers of science. Section 4. Living in the Loop. So, if you can't change the past, what's the point of going? The trick is to stop thinking about changing history and start thinking about fulfilling it. Imagine you travel back to watch the signing of the Declaration of Independence. You stand at the back of the room, just an anonymous face in the crowd. Your presence isn't a paradox, it was always part of that event's history. You didn't change what happened. You were an ingredient in what happened. Your trip wasn't an alteration, it was a pre-written part of the script. One fascinating, though still speculative, idea takes this even further. A theoretical paper by Dr. Lorenzo Gavassino proposes that for anyone traveling on a closed time-like curve, quantum mechanics would force a kind of reset. One of the most mind-bending implications is that memories, which are tied to the increase of entropy, or disorder, would be erased by the end of the journey. As a time traveler completes the loop, the entropy in their system would have to return to its original state, effectively wiping any new information they gained. This offers a powerful, built-in paradox prevention system. You couldn't go back and tell your past self the winning lottery numbers, because by the time you completed the loop, that memory would be gone. You aren't a disruptor from the future. You are a self-consistent part of a space-time loop. From the universe's point of view, you are always there, and your actions are already woven into the fabric of history. You can go back and read a page, but you can't rewrite the words, because your presence was accounted for when they were first written. Section 5. The price of a ticket. This vision of paradox-free time travel is thrilling, but it comes with some seriously unsettling questions. If your actions in the past are already determined and consistent, what does that mean for free will? If you travel to the past, you might feel like you can do whatever you want, but the outcomes will always conspire to keep the timeline intact. This hints at a kind of determinism where your free choices are just gears in a machine that has already run its course. Are we all just actors playing out a script that spans all of space-time? It's a philosophical rabbit hole that physicists are now staring into. And then there's the sheer physical price of a ticket. The conditions needed to create a closed time-like curve are far beyond anything we can currently engineer. We're talking about manipulating the gravity of black holes or harnessing exotic matter with negative energy, stuff that might not even exist. In fact, Stephen Hawking himself proposed a chronology protection conjecture, suggesting the laws of physics might have a built-in defense mechanism, perhaps a violent quantum feedback loop that would destroy any would-be time machine before it could be used. So, while the quantum loophole might solve the paradox problem on paper, the engineering hurdles are so massive that building a time machine is still firmly in the realm of God-tier civilizations. It's a potential solution to a puzzle, but not a practical blueprint. Conclusion. So, where does that leave us? The seemingly unbreakable wall of paradoxes might just have a quantum loophole. General relativity tells us that pathways to the past could exist in the twisted fabric of space-time. And quantum mechanics, instead of forbidding the trip, seems to offer a set of rules to make the journey safe for the timeline by enforcing consistency. You can't go back and change history, but the laws of physics might just let you be a part of it. The past may not be a country you can conquer and reshape, but a place you can visit. A place where, in a way, you might have already been. The door to yesterday isn't locked shut. It's just governed by rules far stranger and more elegant than we ever imagined. And that leaves us with one awe-inspiring question. Is the story of the universe already written? If this trip through time and paradoxes blew your mind, don't forget to like this video and subscribe for more deep dives into the cosmos. Let us know in the comments what mystery of the universe you want us to solve next. Thanks for watching.